In example 4, we're going to get some practice with the concepts of union, intersection, complement, and the universal set. So what we have here are 5 different sets, and we're just asked to find various new sets formed from these given sets, okay? All right, notice that one of the sets, the first set here, is U, okay? So if you see a set designated as U, U is reserved for the universal set, okay? So this is the universal set that we're looking at. And that means all the remaining sets, their objects have to come out of the universe. So in this problem, since the universe contains the numbers 1 through 9, okay, all the remaining sets, R, S, T, and W, they can only contain numbers between 1 and 9. Okay, so everything that's in these remaining sets has to appear in the universe. Okay, because the universe, that's going to contain all the objects or numbers under consideration in this problem. All right, in part A, we are asked to form the new set R union S. Okay, so again, when you see this, this means union. And when you union two sets, you basically join them together. Okay, so remember what I told you. If you're thinking union, think marriage. You get marriage, or you get married, you move in together, you combine all your stuff. So you're going to combine the elements out of both set R and set S. Okay, so let's write our new sets. You're going to have to use your curly braces. All right, so I'm going to start with R. Okay, so R has a 1. Okay, so I'm going to write that down. And notice S also has a 1, okay? I don't need to write it twice, okay? Don't get in the habit of duplicating elements, okay? So just write it down one time. It appears in both sets, but we only need to write it down one time. All right, keep going. So R has a 2, so I'm going to write down 2. And then I'm trying to go in kind of ascending order here. There's no 2 over here, but they both have a 3, so I'm going to write down 3, okay? And then R has a 4. Okay, so we're done with R. And then we need to write down 5 and 7 out of S. Okay, and that's your new set. That's the answer. Okay, so you're basically just performing some operation, okay, and forming a new set. Okay, all right, in part B, we're still going to deal with the sets R and S, but this time we're going to do an intersection. Okay, so remember what I told you about intersection. Think of the intersection of 2 streets. If you were standing right smack dab in the middle of an intersection, you're in the part of the road that's common to both streets, okay? So what you're going to do here is you're going to pull what's in common to both sets, okay? So let's go back to R and S. Look at me, I'm already writing set notation and I don't need to. All right, so let's go back to R and S. I'm going to get ready and put my set notation. Let me erase these things, okay? So we're only going to write down what is in common to both R and S, okay? We know the 1 appears in both R and S, so that's a common element, so write that down. 2 appears in only R. 3 appears in both, okay? So that's another element I'm going to write down. And then 4 is only in R, and then 5 and 7 are only in S. Okay, so here is my new set. The intersection of the 2 sets is the set 1, 3. All right, moving on. In part C, we are going to do S intersected with T. Okay, so now we're looking at sets S and T. Okay, again, this is another intersection problem. Okay, so we're just going to pull what's in common between sets S and T. Okay, so let's go do that. All right, S has a 1 and T does not. Okay, S has a 3, T does not. S has a 5, T does not. 7 has a T, or S has a 7 and T does not. Okay, and then on the flip side, T has a 2, S does not. 4 has, I keep saying the wrong thing. T has a 4, S does not. Okay, so if you look at this, if you compare the elements in each set, there's nothing in common between the 2. Okay, So basically this set that we're making has no elements because there's nothing in common. So the answer here is the empty set or the null set. Okay, so you would just write down the symbol for the empty set. Okay, nothing is in common. All right, let's look at D. So let me scroll down. I'm going to get D. Okay, so we want S complement. That's what you see here. Okay, so remember what S complement means. This means everything in the universe that is not in S. Okay, so what I'm going to do, because I've scrolled away from the initial sets, I'm going to go ahead and write down S again so we can see it. So the set S is 1, 3, 5, and 7. Okay, and we know the universe is comprised of the numbers 1 through 9. So I'm just writing this because I've scrolled away from the set definitions here. Okay, all right, so if I'm going to form S complement, okay, this is going to be a brand new set, so open up your braces. Okay, you're going to write down everything in the universe except what is in S. Okay, so if you look at your universe, here it is, and we're going to take away the numbers that are in S. So S has a 1, a 3, a 5, and a 7. So what's left is going to make up S complement. Okay, so S complement will be 2, 4, 6, 8, and 9. Okay, that is the answer for S complement. Okay, all right, moving on, going back up to example E. Okay, all right, so now we start getting a little more complicated. We have 3 sets involved, and we have multiple operations. We have union and intersection here, and we have a set of parentheses. So I know I've mentioned to you before, when we're working with sets, you want to follow the order of operations. Okay, likely the only operator you will see is parentheses. Okay, but you do want to do the parentheses first. Okay, so we're going to start by doing W intersected with S. And then once we have that result, then we will union the result with T. Okay, so let's do this first. Let's go do W intersected with S. I have both sets right here in front of me. So I have S and I have W. So again, if we're doing the intersection here, that means what's in common. So we're going to pull out what's in common to both sets. So we're going to make a new set. Okay. So let's go through these numbers and see what's in common to both. All right. So if I look at S, I see a 1 and I see a 1 in W. Okay. So that's going to be part of the intersection because they have that number in common. And then S has a 3, but W does not. S has a 5. And so does W. So that's going to be another number in the intersection. And then lastly, S has a 7, but W does not. Okay. W has a 4 and an 8. Those numbers do not appear in S. Okay. So this is the intersection. The only numbers in common to both W and S are the numbers 1 and 5. Okay. So that's what's in parentheses. And so now you've got to union that result with T. Okay, so I'm going to write this down. So I'll go to the next step and I'll write, okay, so now we're going to do, actually, I'll color code it for you. So we'll do, well, I could have kept it that way. We'll do T unioned with this W intersect S. Okay, so I'm going to write down T. Okay, so T is the set 2, 4. Okay, and we're going to union that with our result, W intersect S, that's 1, 5, okay? So if you're doing a union here, okay, you're going to join them, okay? You want to put the elements together, okay? So your final answer here will be just, you know, you don't have to write them in ascending order. It's nice to, it's easier to read, okay? So I'm going to try to organize it that way, okay? Combine the numbers in both sets. I see a 1, a 2, a 4, and a 5. Okay, so that is the final answer. Okay, all right, moving on to F. Okay, F also involves 3 sets. Okay, we see some intersection going on, we see complements going on. So let's start. Okay, first thing I'm going to find is W complement, because remember, you have to follow the order of operations by doing what's in parentheses first. If I look inside the parentheses, it's a lot of intersection. Okay, the way you want to think about this, we have three sets inside the parentheses. We have W complement, R, and S. And we're going to have to do almost like a triple intersection. We're going to have to pull out what's common to all three sets. Okay, so the first thing I'm going to do is I'm going to write down W complement. Okay, so remember W complement means if you go to W, W's up here, okay, we're going to go to W and we are going to look at it, and to get the complement, we're going to go to the universe and take out everything that is in W. Okay, so here's the universe. I have it highlighted. I'm going to take away what's in W. So W has a 1, a 4, a 5, and an 8. So what's remaining is the set W complement. So that's going to be 2, 3, 6, 7, and 9. Okay, so that's W complement. We are going to intersect that with R. Okay, so R, we're not changing it. Okay, it's right here. Okay, go back to the definition. It's 1, 2, 3, 4. Oops, skipped a number. So it's going to be 1, 2, 3, 4. And then still inside the parentheses, okay, I've got to intersect again with S. Okay, just S. Remember, this prime is on the outside of the parentheses, so we haven't applied that one yet. Okay, so the set S, we go back and look at that. Okay, that is just 1, 3, 5, and 7. So I'll put that in green. Okay, so 1, 3, 5, and 7. Okay, and we're intersecting all three of these sets. So we need to figure out what's in common to all three. Okay, so let's start. I see a 2 in the red set and a 2 in the blue set, but it's not in the green set. Okay, so that's not common to all three. All right, I see a 3 in the red set, a 3 in the blue set, and a 3 in the green set. So that's common to everything. So it's going to be part of the overall intersection. Okay. All right, in the red set, I have a 6. There's no 6 here, no 6 here. I have a 7 in the red set, no 7 here. Okay. And then lastly, I have a 9 here, okay, but no 9 in blue and no 9 in green, okay? So the only element that all three of these guys have in common, okay, is going to be the 3, okay? So I'm going to write here, okay? Remember, we just did W complement intersected R intersected S, okay? And so that result is just the set 3. Okay, so that came from all this work. Okay, all right, so that is this piece. Okay, that is the stuff inside the parentheses that we just did. Inside the parentheses, we have W complement intersected R intersected S. Okay, and once we simplified that, we figured out that's just the number 3. Okay, all right, so then remember, you have to apply the outer prime. Okay, so you want the complement of this. Okay, so to form the last piece here, okay, we're going to do the final answer. So we're going to do W complement intersected R intersected S. Take that result that we just did, which is the set 3, and now we're going to find the complement of that. Okay, so this is going to be a set. Okay, this means go to the universe. It's going to be every number in the universe except what is in this set highlighted in blue. Okay, so it's going to be every number in the universe except the number 3. Okay, so our answer will be 1, 2, 4, 5, 6, 7, 8, and 9. Okay, there's the final answer. Took a little bit of work. Okay, all right, a couple more. All right, G. Okay, this is an interesting one. Okay, G is asking you for the complement of the universe. All right, so again, I've scrolled down, can't see the universe anymore, but if you remember, the universe is the numbers 1 through 9. Okay, and remember what universe means. Universe means that in this problem, these are all the numbers under consideration. We're only considering the numbers 1 through 9. Okay, so what universe complement is saying, we want everything that's in the universe that's not in the universe. Okay. Universe. Okay. So you're going to go to get your new set. You're going to go to the universe and you're going to get rid of everything that's in the universe. Okay. So you end up getting rid of everything. Okay. So you end up with a set that has no objects. Okay. And so this is going to be the empty set. Okay. All right. The last one, part H, okay, is asking for the complement of the empty set. Okay. So again, remember how complements work. Okay. You've got to start with the universe. Okay. The universe here, numbers 1 through 9. Okay. So if you're finding the empty set complement, that means go to the universe and take out every object in the empty set. Okay. Well, the empty set doesn't have any objects, so you can't really take anything out. So you just get left with the universe. Okay. So this is kind of cool. Okay. The complement of the empty set is the entire universe. Okay. And remember, that's the opposite of what you saw in G. Okay. The complement of the entire universe is the empty set. Okay. All right. So that was just some practice with union, intersection, and complement.